This is the second page of the Chapter 6 test review for Algebra 1A. Okay, picking up here with number 7. So number 7 says the parabola represented by y equals 2x squared is translated 7 to the left and 5 down. So first I just want to know what translation would perform that. Okay, how would we write that in translation notation? Okay, so remember with translations we always use a T. Okay. And then 7 to the left would be a -7, and 5 down would be a -5. Okay. Now, this next question, I know this is on a lesson master somewhere. I don't know if we've talked about it a ton other than that, but it's pretty easy. This is saying the point 3, 18 would have been on this original graph. And I just want to know, where does that point end up if I do this to it? So really what we need to do is apply these two things, these two processes, to this coordinate. So I'm going to take the 3 and subtract 7, and that would take me to -4. So if I was at +3 on the x-axis and I shifted 7 to the left, then I would end up over here at -4. Hopefully that makes sense. And if I was at 18 along the y-axis and I shifted down by 5, I would end up at 13. So then I would just want to take those two things and write them back together as a coordinate. -4, 13 is where my new coordinate would be. Okay, so now write an equation in vertex form. And this is pretty easy because remember that this is really your h and your k right here. So my vertex form formula looks like this. Y minus k equals a times x minus h squared. So I'm going to say y, this would be my k value right here, okay? H, k, and then this up here is going to be my a value. We'll talk about that in a second. So when I go to do y minus -5, that's really going to be a +5. My a value comes from that original equation's a value, which is a 2. So this would be 2. And then x minus -7, that would really become a +7 squared. So this right here, that's all we have to do for vertex form, is drop the numbers into the formula and leave it alone. Okay? All right, and then rewrite this equation in standard form. Now, standard form is the one that's like ax squared plus bx plus c. But remember, you can't just look at the equation and come up with those values. Really what I have to do is just simplify this guy. I just have to follow my order of operations. So I'm going to square first, meaning I'm going to duplicate that parenthesis, x plus 7 times x plus 7. Go ahead and do the FOIL right here. So y plus 5 equals 2, and then x times x is x squared. X times 7 is 7x. 7 times x here is 7x. 7 times 7 is 49. Okay. Leave this all alone. By the way, I have a lot of students who like moving that 5 right away at the beginning. That's totally fine too. It would just be sitting out here as a -5 on this other side. I'm going to go ahead and put my 7's together. So x squared plus 14x plus 49. Okay. My next step mathematically would be to take care of that 2. So we're going to distribute the 2. Y plus 5 equals 2x squared plus 28x plus 98. That was me multiplying all 3 of these things by 2. And then my last step here would be to move this 5 over to the other side. So -5 minus 5. Again, doesn't matter if you did that before. It's still going to be the very last thing you really put together here. So 2x squared plus 28x. And then 98 minus 5 would be 93. Okay. And there you go. That would be your parabola in standard form. Okay, 8, 9, and 10, I'll be honest, we haven't talked about a ton in class, so I wouldn't stress about them too much. Okay, we'll make sure to cover them before you take the test. But really, anytime I'm asking you to graph one of these things precisely, I'd be using your calculator. Okay, for example, number 8 here, I would type in as 5x squared minus 20x. Okay. You can go ahead and graph it to get an idea of what it's going to look like. All right, and I think that I made this one so it doesn't fit real nicely on your graph here. We can either just make do or we can count by twos or something like that. But then I would, look at your table. And some people look at this table and kind of freak out, like, oh my gosh, we can't get numbers that big on our graph. I agree with you. We can get whatever we can fit nicely onto our graph. And again, you may want to consider counting by twos here because these numbers are pretty ugly. But I can kind of pick and choose. So like 0, 0, I know I can get that one on my graph, right? 1 and negative 15. Well, let's see. This is negative 10 right here. So negative 15 is going to be pretty low down here. I'm just going to stick it right above this problem. 2 and negative 20, we know that's going to go way lower. 3 and negative 15, so that would be, here's 3. I'm going to put that at the same level, and we know that negative 20 is going to go down here somewhere. And at 4, I'm back up at 0. Okay, and then probably by 5, I'm up at like 25, yeah. Okay, so those numbers get really big. So this was kind of a bad one for me to ask you to graph by hand here. But we know this is going to be a pretty narrow parabola. We know this thing would actually dip down here. I don't want to cover up my question here. And then it would come back up like this. Okay, so don't stress about that one too much. I don't love that problem. Okay, this one, I think it's almost more important that you not do this one precisely. I want to just see, can you pull the correct information out of this thing? So if it's written in vertex form, we should be able to identify the vertex right away. And in this case, that would be, remember, it's the opposite. So it would be negative 2, positive 4. And from this 1/2, I would want you to say, well, it's going to open up because it's positive, and it's going to be wider than normal because it's less than 1. So negative 2 comma 4 would be here. And then I would want to make sure that we're going up and that we're a little bit wider than normal. Okay, so something like this, I wouldn't worry about having to do precise. I actually would prefer it if you could just pull these pieces of information out of the equation. You could put this in your calculator if you wanted to. You would have to swing that 4 over to the other side. Okay, you wouldn't have to put it all the way into standard form. You wouldn't have to FOIL it all out, but you would have to make it, let's see, 1/2 times x plus 2 squared. And then that minus 4, if we were to swing it over to the other side, would become a plus 4. And then we can take a look at the picture and just make sure it kind of looks like what we think it should. Okay, and then yes, I could go into my table and get some precise points here, but with that one, I'm less concerned about that. Okay, and then for number 10, let's go negative 2x squared plus 4x minus 1 graph, just to get an idea. Okay, so this is what our picture should end up looking like. Go into our table. And again, we can just kind of pick and choose the numbers we like to graph. So negative 17 might be hard to graph, but negative 1, negative 7 isn't too bad. That'd be right here. 0, negative 1 would be here. 1, 1 would be here. 2, negative 1 would be here. And you should see with all of these parabolas kind of that symmetry. Whoops, put that on the wrong line. This goes with the 3. Where the points on one side match the point of the other. That's because of that axis of symmetry idea that we talked about. Okay, so that's where that graph should be. Okay, so I'm just going to put a note here in case you're just looking at the answer key, that this is coming from the graphing calculator. Okay. All right, so really, number 9 is going to be pretty similar to what, I was going to say number 9 is very similar to what we're doing in number 9. Looks like I numbered that wrong. Sorry about that. This one is going to be very similar to this. I want to be able to look at this equation and just identify what the vertex would be. So the vertex, again, comes from your h and your k, opposite of what it looks like in the equation. So it would be negative 2, positive 3 would be my vertex, opposite of those two numbers. And remember to do the x number first. We also know from this 4, when I go to sketch my graph, that this thing is going to open up because it's positive, and that it's going to be skinny because it's greater than 1, okay, that 4 is bigger than 1. So if I just wanted to sketch this graph, I would go to about where my vertex would be. -2, +3 might be, I don't know, here-ish, okay? We want it to point upward and be skinny. That's what I really want you to be able to see here, okay, up and skinny. And then rewrite in standard form. We did that in part D up here on number 7. In standard form, we just want to take this thing and simplify it. We want to FOIL. Okay, so I'm going to fly through that probably kind of quickly here. Y minus 3, 4 times x plus 2 times x plus 2. Distribute my x through first, so I end up with x squared plus 2x. I'll distribute this 2, so I get 2x plus 4. Still have the 4 sitting outside with the y minus 3 over here. I'm going to go ahead and jump a step here. And if you're confused about the step that I'm about to do, look back up at the second, set of steps that I did in this one. I'm going to distribute this 4 and see if I can combine my middle terms at the same time. Okay, so I know right away 4 times x squared would be 4x squared. This would give me a 4x, and then I multiply it by the 4, so I get a 16x. And then at the end, 4 times 4 is 16. Some of you may be getting to the point where you can take little shortcuts like that. That's okay with me. If not, go ahead and write that out as 2 separate steps. And then last thing would just be to add the 3 over to the other side, so I end up with y equals 4x squared plus 16x plus 19. And once again, I know what this thing should look like, okay? So I can always go into my calculator and graph it. 4x squared plus 16x plus 19, and just see that it looks like what it's supposed to, okay? And it does, all right? I mean, I drew mine a little high, it looks like, but in general, it's in the same location, it's got the same attributes, so that's kind of what you're looking for with a problem like this one. Okay, I will wrap up the last part of this review with a third video in just a few minutes.